Okay, so let's go ahead and look at how to do the opposite, essentially. So we're going to look at going from atoms to grams, all right? Instead of going from grams to atoms, we're going to work the opposite way. So how many grams are in 4.32 times 10 to the 24th atoms of gallium? Okay, how many grams are in 4.32 times 10 to the 24th atoms of gallium? So let's go ahead and find gallium on the periodic table first. Gallium is number 31. Okay, gallium is number 31 is Ga, and its molar mass is about 70. So it's about 70 grams per mole. Okay, so that's pretty much what gallium would look like on the periodic table. All right, number 31, Ga, 70 grams per mole. Now we can go ahead and set up our problem here. So we're trying to figure out how many grams are in 4.32 times 10 to the 24th atoms. So this is our given. 4.32 times 10 to the 24th is our given. So that's what we're going to start our dimensional analysis with. So 4.32 times 10 to the 24th atoms of gallium. Okay, that's how we start our dimensional analysis out. Always start with your given in the top left box. All right, whatever the problem gives you is what goes here. All right, now we're in atoms. And we're trying to get to grams. We can't just go straight from atoms to grams. We have to go from atoms to moles and then to grams using the molar mass. So we need to get to moles first. We are going to have to use Avogadro's number again, but instead of putting 6.02 times 10 to the 23rd on top, we need to put 6.02 times 10 to the 23rd on bottom because atoms need to cancel out with atoms. Okay, if we put moles on the bottom, we'd have atoms times atoms divided by moles. Atoms squared over moles, and that means nothing. So we're going to have 1 mole of gallium on top, and we're going to put 6.02 times 10 to the 23rd atoms of gallium on the bottom. Okay, still using Avogadro's number the same way as a conversion rate between atoms or particles or molecules and moles, just in this case it's on the bottom instead of being on the top. All right, before we move on, check our units. Atoms of gallium, cancel, cancel. The only thing we're in now is moles of gallium. Perfect. Moles are like the mediating point between atoms and grams. Okay, if we're in atoms, we want to get to grams, we have to go to moles first. If we're in grams and we want to go to atoms, we have to get to moles first. Moles are like the mediating factor between the two. So now we're in moles of gallium. All right, we know 1 mole of gallium is going to go down here automatically because moles of gallium need to cancel out. We need to cancel those units. The number that's going to go on top here is going to be our molar mass, which is 70 grams of gallium. Oops. Okay. So instead of using our molar mass as the second number in our equation like we did when we were going the opposite way, we're using it as our last number of our equation. Okay. So it's going to be gallium. Oh my gosh, I keep capitalizing the A. There we go. Okay. So 4.32 times 10 to the 24th atoms of gallium times Avogadro's number, 1 mole of gallium over 6.02 times 10 to the 23rd atoms of gallium, and then we have times the molar mass, so 70 grams of gallium for 1 mole of gallium. Moles cancel out. We're left with just grams of gallium as our units. We were looking for how many grams of gallium, so it cancels out really well. Okay, so now we need to multiply the top first. 4.32 e to the 24 times 70. Okay, so that's what it's going to look like in your calculator. 4.32 e to the 24 times 70 gives us 3.02 times 10 to the 26th. And then we have to divide by 6.02 times 10 to the 23rd. So, whoops. Divided by 6.02 e to the 23rd. Again, you can just hit divide straight away, and it just uses the previous answer as your next term, and then divide by 6.02 times 10 to the 23rd, and we're left with 502 grams of gallium. Hopefully you can see it over here. 502 grams of gallium is our answer over there. Okay. So, start off with our given. Okay. Multiplied by Avogadro's number, in the inverse of Avogadro's number, 1 mole over 6.02 times 10 to the 23rd. We do that because we need to cancel out our atoms of gallium. Okay, atoms divided by atoms cancels to 1, which means it doesn't affect our equation anymore. And then we need to multiply by the molar mass, grams per mole, moles of gallium on the top, moles of gallium on the bottom, because, again, we need those terms to cancel out. They need to divide out to 1 so they no longer affect our equation. We were looking for grams. The only unit we had left was grams. So now, once we get here, we know that everything has to be correct. So as long as we multiply and divide correctly, the answer will be correct. Okay? As long as everything is set up correctly, it's very difficult to get the wrong answer on these. All right?